Hey, hi everyone. I'm Akshay here. Just one second. I work here at Rippling in web platform team. Recently, we completed migrating React to the latest version, and this talk is mainly around that. So I will be going over how we did the upgrades like without breaking much things. So let's get started. So in this talk, I will be mainly covering about how we upgraded from React 17 to 18, challenges around enabling concurrent mode, then how we went from 18 to 19, the final and the latest version of React at present. So before we just start with this, right? I've just quick question with all of you guys. Like, can I get a quick show of hands? Like, how many of you are on React 18 version in your workplace production code basis? Okay. What about 19? Okay, nice. So I think a lot of people have to upgrade to 19 yet, and I just see very few on 18 as well. So hopefully this would be worthwhile. And so to upgrade to React 18, what we did is like if you go over the official upgrade guide, it will just present it as a one-step upgrade process. So, but it doesn't work in our scale. For example, we have about more than some 60K files and a lot of dependencies as well. So how would you go about the upgrade? So to do that, we break it up in a two-step process. The phase one is like you would bump the package.json version to React 18 and then fix the types. And in the second part, you would enable the concurrent route. So I would talk more about what actually concurrency is in React 18 in the later slides. So this is how it looks like. For example, if your app is using React DOM.render, then it's using the legacy mode. Uh, it's the non-concurrent version of React. If you're on the create route, then you're using the concurrent React in your code bases. So in the phase one, what you should be doing is like, it's mainly around fixing the types. So with React 18, lot of types around how children's are handled in functional component changes, and couple of types around use callback and context also gets changed. So you would encounter a lot of breakages around props.children in your code base. Most of these things get fixed with a code mod which React team provides. It's like fairly decent. So they should cover this particular part. And like what you get out of doing all this, the phase one. With phase one completion, you can actually use these hooks, like which are mainly use ID, sync external store, and insertion effects. But you should note that at this particular step, you can't use any of the concurrent mode features, that is your use transitions, use deferred value, all those things. And concurrent mode specific features like batching also doesn't kick in yet. So what's next? Next part is once you have resolved all your TypeScript issues and you're on React 18, you can move to the phase two, that is switching to the concurrent renderer. Concurrent renderer is nothing but these two lines of code that is using the create route and just calling root.render. This two-line change, you would expect that, okay, things should work seamlessly, but that doesn't happen. A lot of things do break. And why is that? So let's understand concurrency a bit more. So in React 17 or with even React 18 with the legacy route, what happens is if your rendering is going on and a user clicks some button, right? Or maybe types some input. In that scenario, the rendering doesn't get interrupted. Your events are handled at the very end. But with React 18 in concurrent mode, the click handlers, your type inputs gets prioritized and rendering process is paused in between to give priority to this high priority things. So your app remains more responsive and users get a better performance. There are few other things which kick in with create route. Those are mainly batching works everywhere. Batching is around how your state batching is handled. Then rendering is now interruptible. You have more hooks to handle performance. That is your use transition and deferred value would start working in. Then you would have changes in how strict mode uh, works in React. So strict mode is a development only feature where React can help you catch bugs. So this would also start kicking in. Then there are also changes around suspense boundaries. I would explain more on this in the later slides. So first, let's understand what is automatic batching. So if you look at this particular slide, can anyone tell how many renders this would cause? Like one? Yeah, because the states are actually batched together. But in React 17 world, it would cause you two renders. So you can see that the states gets batched and it would result in a less number of rendering. The same thing actually applies for promise and native events as well. By the way, React 17 also had batching, but those are only for click events, like the synthetic React events. But with 18, they expanded it to a lot of other surface areas like promises, native events, and async functions and all that. And what else? So now you have strict mode working in with concurrent mode as well. So the strict mode changes are mainly like your React application would mount, unmount, and remount. So this weird behavior React introduced to catch bugs in your code base, which are not concurrent mode friendly. So the thing with concurrent mode is your app can render, it can pause the rendering step and come back to it. So that's why this effect cleanups are very important now. So this would expose a lot of bugs, and you should like expect to see couple of regressions in your development mode for sure, like whenever you do the upgrade. And the suspense also becomes more stricter with this. So the thing is, with React 17, if you had some missing suspense boundaries, your application still used to work. But now with React 18, you need to ensure that the suspense boundaries are there at appropriate places. What you can expect is like see a lot of spinners on your screen, like some pages may not load, like if you have some custom implementations on your like route loading level and all that. So let's look at the things which break with this particular upgrade in detail. So in our case, like we had a lot of E2A failures which we had to fix. Same thing for unit test, and third-party packages are a complete different story. Like you would have a lot of incompatible packages which doesn't work at all with concurrent mode. So the thing is like you should definitely start fixing with A2A tests first. Like that would help you build some confidence. Then later on, like you can move into fixing your unit test as well. I would like discuss few strategies like how one can approach fixing unit tests at this scale. Like in a sense, if you're having more than 300 test suite failing, how would you even approach that? And a few other types of bugs which you could encounter is like you would expect a particular set state to be instantly visible. For example, here we are setting state in data and instantly accessing it in the very next step. So this seems like we already know not to expect synchronous state updates in 17 world, but this used to work. So we can't say that the code was buggy to begin with, but all these things start to act up in React 18. It would just break your application and you need to fix all these issues before you go forward. Then next is you should look at your custom implementations around route loading. For example, we had a wrapper around um, loading React routes. We built it on top of React router. So those things also started behaving weird because now since React can pause the rendering in between and come back to it, you need a stable reference to your route promises. For example, if a route already started loading and React just went away and came back, that loading step should still complete if you're coming back to the same step. So we had to do some couple of hacks around using weak map and all that to maintain stable references, and that just works. Then there is things around strict mode. So with strict mode, as I mentioned earlier, your assumptions that uh, unmounting can only happen like in one step is now completely incorrect. Your application can mount, unmount, and remount instantly. It would expose a lot of bugs like where you're maybe mentioning a state like is unmounted and all that. Your assumptions would start breaking and would expose a lot of other issues. So this is something you should look for if you're going around this upgrade. Then there is the thing around missing suspense boundaries. So all your routes needs to have proper suspense boundaries again. Otherwise, you would end up seeing blank pages a lot. Now coming to third-party packages. So how we did is like we initially made a complete list of third-party packages which are not compatible with React 18 by looking at the peer dependencies. Now the thing with packages third party is they don't have proper peer dependencies always. So a package can still mention that their peer dependency is compatible with 18, but it would still break with your 19 application. So the thing is, create an initial list of packages which can break with the peer dependency, audit them. If they are not working properly, then just upgrade them to a proper version, or in some cases, you would have to replace it altogether. For example, in our case, React Beautiful DND didn't had a 18 compatible version. So we had to replace it with some other library. But for React 18 and Next, it had a compatible version in V14. So we just went ahead with that upgrade for it. Cool. So now let's talk a bit about unit tests. So the thing with unit test is a lot of your unit tests start breaking once you enable concurrent mode in that. And how you enable concurrent mode in that is your React testing library has a property called legacy root. If you just set it as false, your concurrent mode would start working. By default, this is true. So what you can do is like you can roll it out in folder wise approach. You can have a particular list of folders where you want to step by step enable concurrent mode and then start fixing all those bugs. But now the question comes like, what are these issues that arrives in your unit test, right? So let's have a look at that. So you would see a lot of act warnings in your unit test, and get by in your unit test would start failing. And one very weird part would be your unit test would pass in your local environment, but would fail in your CI. This is like very tricky to fix at a times. So I would explain like why this happens. And some of the state updates would also appear late. So actually what happening in behind the scenes is, since your app is using concurrent mode to render, the rendering can depend on the CPU cycle as well. So if your CI environment is having a lower CPU count than your local system, your render output might differ a bit based on the timing. And this timing assumption is the thing which breaks things. So how do we have a proper foolproof unit test, right? That is to have proper expectations around your test. Like always look for DOM updates, which would happen eventually rather than depending on like immediate state changes. So what you can do is like prefer to use find by text over get by text. So the thing with this is it supports retry mechanisms. So it would make your test more concurrent, more tolerant, and always wait for state transitions. These things would help you have non-flaky tests. And timers also start acting weird in concurrent mode. So using like this neat trick of advanced timers would help you fix over all those things. So now the thing is like I mentioned that we had about 300 flaky tests, which would just act up in CI sometimes, and some of them would even fail on your local system as well. So how would you fix that? The step is like just dump all these patterns in a agent skill file and just have it iterate on all this flaky tests, like let it run, and that should be helpful. So yeah, once you're done with all these things, what you can do next is like it's time for rollout, right? Like we have like fixed the integration test, unit test, and all that. Now, how do we roll out React 18 concurrent mode properly? So the thing is like it's just a two-line changes actually. So you can have this behind a feature flag. So we use launch darkly internally. That's like a feature flag testing tool. You guys can use any other solutions as well. The idea is like to roll this out slowly in batches to different set of users. If they are experiencing some issues, just roll back the feature flag. It's way quicker than just doing git revert and deploying things. Cool. So I think we are now in the React 18 to 19 part. So let's say now you want to upgrade to 19, right? So the prerequisite for that would be you need to complete your 18 migration. Like you need to be on concurrent mode, since in React 19 there is no non-concurrent mode version of that, what we have in React 18, right? And all your tests, unit tests also need to be on concurrent mode. Like your legacy root should be false. Like if you're having it true, then it won't work in 19. So yeah, I mean, prerequisites completing 18. So let's see what actually changed in React 19. So if you look at the React 19 official upgrade guide, it also again is presented as a one-shot upgrade. But as I mentioned, right, dividing things in phases is the way to go. I would explain like how we divided 19 into a separate phase as well. The first part is like handling types and a lot of um, React specific APIs which got removed. You would handle those in the first part and then you do the actual rollout. Would revisit the rollout in later slides. With React 19, your suspense related things remain same. Initially, when React 19 came around, there was some drama around how suspense is handled. So it used to result in a waterfall fetch model. That's why there was a lot of discussions in the community. Later, React 19 had a similar behavior what we had in 18. So there was no drastic change with suspense, but it's just minor improvements around that. So your application still would function same without any code rewrite around suspense at least. So yeah, coming back to our upgrade approach, that is like in the first part, you would get your entire code compatible with React 19. And then you, at a very later phase, do the package flip, like merge your React 19 package version into your main code base. Now, the thing with first part is React 19 removed a lot of these type of mechanisms like prop types, default props. These APIs are now all deprecated and won't work at all. You need to get rid of all this. So what we did is like we initially created a ESLint rules for all these deprecated APIs that would help us catch all the places where these particular APIs were removed. There are a few community packages as well around React 19 ESLint rules, which would flag you all these deprecated APIs, but they were like kind of limiting. So we went ahead with creating custom ESLint rules internally for that. And also had to create a couple of internal utilities. So our code base is compatible with both 18 and 19. So now the thing is, with this upgrade, you would have again the same problem. Like you have a lot of TypeScript issues to fix, and then same thing with this deprecated APIs. Like you have to remove default props and all that. So how would you approach that? Here again, the AI agents come to rescue. You just create a proper skill file with that, like feed in proper before after edge cases, and just let the agent run and review the final outputs. Like these are more uh, like kind of minute upgrades around how your code is. If your code is having a lot of legacy things, then it you need to review it thoroughly. Otherwise, it should be good enough. So React team also provides code mods, but the thing with code mods is code mod would make a lot of changes in your code base which are not in terms compatible with your coding patterns and all that. So let AI agents take over that. So yeah, so what challenges did we face with rolling out React 19? So unlike React 18, like we couldn't use a feature flag approach because React 19 is or React in general is a build time dependency, right? It would create a separate build. You can go around hacks with having multiple versions of React in your code base, but that's not ideal. I mean, it would introduce a lot of other edge cases and a couple of issues as well. And if you're having React compiler like us, you won't be able to do that. So what we did is like we created two separate builds on production, one with React 18 and 19. It's similar to a canary setup, which you have at a couple of orgs. So what happens is the traffic gets split at the infra level itself. From the load balance, it would just land on the 19 build, on the 18 build. And this makes it like too quick to iterate over. If you're facing some issues, you can just roll back the traffic percentage and the issue is resolved and you can fix it in meantime. So if you look at the React 19 upgrade doc, you would see that uh, like all this looks like semantic changes and nothing should break, but the story is completely different. So a lot of things do break. So there would be some paid breakages in that because rendering is less tolerant. Like we had a case like where one particular page already had an infinite render that shouldn't be working in the first place though, but it somehow worked in 18. But with 19, just broke. And this just indicates that React 19's error tolerance is a bit less than what it had in 18. And there are also differences around React suspense as well. In a sense, suspense boundaries are more stricter now. So if you are having some missing suspense boundary, uh, then it would just help. It would just cause a breakage around your UX. It shouldn't be working in 18 as well. I mean, it should flag issues, but what I've observed is like it somehow works in 18, but in 19 it would cause issues. And the thing with third-party packages, so a lot of third-party packages actually use React internals, which were changed in the 19 release. Let's have a look at them in detail. So the thing with third-party packages is like I've seen a couple of packages were using this thing, secret React internals, which they shouldn't be using ideally though. And this thing got changed a lot in React 19 and just ended up with broken packages in the ecosystem. So we had to patch few packages at couple of places, like we didn't had any 19 support. For the other scenarios, we just upgraded to the version where 19 was working. Again, the peer dependencies can be very misleading, but this is just one way you can just narrow down your packages you have to audit, but don't rely on the peer dependencies blindly. If a package is saying that, okay, they just support React 19, just have a look. If it's not peer dependency greater than 16 or 17, like some packages just blindly mention, okay, we support all the peer dependency greater than 16, 17, but they do tend to break with 19. Cool. So now what you get out of React 19? So with React 19, you have a lot of improvements around React compiler. You can think of 19 as a like new way of writing code in React ecosystem, mainly because React compiler is now way more mature with 19. You won't have to worry about like using memorizations, use callback and all those things. The compiler can just take care of that. How you write or pass ref code is now completely changed. So there is no need to use forward ref anymore. You can just pass ref as a prop, uh, like any other prop, right? And there is use hook and a couple of other hooks around UI optimizations. So this would help you build a very performant app. So now the thing is like there are still gaps in the ecosystem around React 19. These are just a couple of gaps which we encountered. We used to have a click to code tooling. I mean, you can just click on the front end UI and it would open the editor code. We used to use a tooling called Locator.js. It was pretty nice and used to work in React 18 versions, but with 19 it just stopped. So then we moved to a different tooling called Code Inspector, but again it was having a couple of gaps with the 19 thing. So we had to patch it and just what you should try is like if you're seeing gaps in the ecosystem, just contribute it back. So would help others people as well. Same thing with under dev mode bug which we encountered. So in React 19.2, there's a like recursive prop inspection bug in dev mode. So what happens is React 19.2 introduced a thing called performance tracks, so which observes your re-renders and would have a specific UI in your performance display tab. So for that, what it does is it would inspect all the re-renders and check why this particular re-render happened, right? But that thing has a bug where it would also inspect cross-origin iframes. So that iframes would end up triggering issue that you're trying to access some cross-origin iframe within React. So this bug is still there. So if you just stumble across this, just do some workarounds. So uh, like that iframe doesn't load for now in the dev mode. That is what we did, but waiting for this fix to be live. Then there is some library adoption lag as well. Like a couple of packages are not yet 19 compatible, but in our case, we managed to get most of our packages which we rely on 19 compatible, but there are still lags in the ecosystem. So you would encounter a lot of issues around that as well. If you're like using some legacy packages like and design or something, then it's pretty tough. So what are the like key takeaways of this? So that is like you should split your upgrade into phases. In large code bases, you can't just go around and do the upgrade in one single step where you just merge the 18 packet version bump and the 19 version. So always try to divide things in different phases and try to leverage feature flags and having traffic split for build time changes, like as we did for 19. And also invest in ESLint rules for at least for the 19 upgrade. This would help you catch regression. So what I've observed is when you use AI agents to refactor a lot of code, they would tend to miss out on a few aspects, like you would miss out migrating a particular module in one random file. That's why you need proper ESLint rules to catch all these things. And yeah, leverage AI agents and skills files as much as you can. Like what I've seen is like things using it's way better than using code mods in a couple of use cases and would definitely help fast track your upgrades. And third party packages are a wild card. Just be very careful. Like uh, do a thorough audit for that. Otherwise, you would end up with some broken build on prod. Thanks a lot, folks. So we can maybe have a quick questions around this, else we can wrap up.